Okay, so we're going to go through some of these problems I didn't get to in lecture. Just give you the walkthrough on how to do them. So if we're going to convert 9,255 centimeters cubed, or cubic centimeters, to gallons, I'm going to start out with our given here, 9,255 centimeters cubed, and hopefully you've tried these already on your own, and you're coming here to look for some more guidance, so feel free to pause at any point and try and work things out on your own as much as possible. So we're going from centimeters cubed, and we want to go to gallons, and the key here is that units of gallons, this is a volume, and we're starting with centimeters cubed, which is also a volume. And as we talked about before, it's a derived unit of volume, but we can convert this into milliliters. And part of the reason that we know we want to convert into milliliters is because we have this conversion over here that says 1 gallon is equal to 3.785 liters. And if we get to milliliters, then we can convert from milliliters into liters. So the unit that we want to cancel out is centimeters cubed. Milliliters goes on top, and then we want to go from milliliters into liters. So 1 milliliter is 1 times 10 to the negative 3 liters, and then 3.785 liters is equal to 1 gallon, and then that'll give us those units that we're looking for in the final answer. Now pay attention to this fact that we didn't need, like when we talk later in the lecture about those power units to a power, converting those centimeters cubed to milliliters, we don't need to cube anything when we're doing the conversion because this is already a unit of volume, and it's a derived unit of volume. If we were going from centimeters cubed into inches cubed or something like that, then we would need to do that. So we take our 9,255 times 1 e to the negative 3, and then divide by 3.785. So everything the calculator gives me here now, that is 2.445178. I guess not quite everything, but more than we're going to need. And because this is a defined quantity, this is not a defined quantity. The 1 gallon, that is exact. The place that might limit your units here is the other side of this. So there might be, very well, probably are, more decimals after this, but fortunately in this case, because we're doing all multiplication and division, these have the same number of sig figs, so our final answer will be 2.445 gallons. Right, on to the next. Apologize for my sniffling. So convert 5.52 times 10 to the negative 5 centiseconds to microseconds. And this is where you need to memorize these metric prefixes. So 5.52 times 10 to the negative 5 centiseconds. We want to get to microseconds. You might need to pull up a chart for this one. And part of the key here is that it's easier to convert from one prefix to another if you first go to sort of the common base unit in between. So common base unit here being seconds. So if I can convert centiseconds into seconds, so 1 centisecond, and centi means 1/100th. So 1 times 10 to the negative 2 seconds. And then we're going to convert our centiseconds into centiseconds into microseconds. So microseconds is 1 times 10 to the negative 6 seconds. So 1 microsecond is 1 times 10 to the negative 6 seconds. A millisecond would be 1 times 10 to the negative 3. Oop, not another, there we go, multiplication, or I mean equal sign. So 5.52 times 1e to the negative 2 divided by 1e to the negative 6. This is going to be 5.52 times 10 to the 4th microseconds. And because we're all doing all multiplication or division, and our unit conversions here are all from one metric prefix to another, then we keep the same number of significant figures as our initial number. And we can do an additional check here. So if 1 centisecond is 1 times 10 to the negative 2 seconds, and 1 microsecond is 1 times 10 to the negative 6 seconds, then a microsecond is a smaller unit than a centisecond. Because it's smaller, it's going to take more of them to make up the same amount of time in this case, because we're talking about seconds. Okay, moving on. Again, make sure you're pausing at any point here when you need to. This question is a little bit trickier, but only because of the context that it's giving around all of these, you know, it's a word problem. So it gets a little bit confusing maybe, trying to parse out the important information. But we can highlight some things here. So a vineyard has 145 acres of Chardonnay grapes. A particular soil supplement requires 5.50 grams for every square meter of vineyard. How many kilograms of the soil supplement are required for the entire vineyard? All right, so I've highlighted some of the important things here. And so we can write out our information. So we have 145 acres. We have 5.50 grams. And this is kind of a alternative wording for saying something like per. All right, so this is 5.50 grams. We could replace this for every with per. So 5.50 grams per square meter. And we can rewrite that over here as grams per meter squared. And then the thing that we're looking for is how many kilograms of soil supplement are required. Okay, so this is where my general advice of look for the number that's not a conversion factor comes into play. So 5.5 grams per meter cubed, or squared, excuse me, that is 1.45, or sorry, back it up a little. So 5.50 grams per meter squared, that is a conversion factor. It's telling us how many grams we need per meter squared of vineyard. The only thing that we have here that's not a conversion factor is the 145 acres. So we're going to start with 145 acres. And we want to know at the end of all of this, how many kilograms of soil supplement do we need? And we're also given 1 kilometer squared equals 247 acres. So the only thing that we can actually convert right now is from acres to kilometers squared. So we can start there and we'll say 247 acres. And the reason that's the only thing we can convert is because that's the only unit that we can cancel. And so that's 1 kilometer squared. Okay, and that gets us closer to this, 5.50 grams per meter squared. But now we got to convert meters or kilometers squared into meters squared. And this is where we're using units raised to a power. So we can write in our sort of base conversion here. 1 kilometer is going to be 1 times 10 to the 3 meters. And then we're going to take that whole thing and square it. And that means we're squaring the number and the unit on the top and the bottom. Okay, so now that gets us to meters squared. And then we can use our 5.5 grams per meter squared. And then we can convert grams into kilograms. So 1 kilogram is 1 times 10 to the 3 grams. And now our units there at the end on top match the units that we're looking for overall for the question. So 145 times, and this is where we're going to use that square, 1 times 10 to the 3 squared times 5.50 divided by 247 divided by 1 times 10 to the 3. And so this farm plot is going to require 3.23 times 10 to the 3 kilograms of soil supplement with the correct sig figs. And again, we don't have all exact conversions here. This is not an exact conversion, and this is not an exact conversion, but it's okay because the number of significant figures here matches that of our initial number. Also, just to show you what this looks like if you type it into your calculator, I recommend for any of these times 10, the exponent part of scientific notation, I recommend that you use the E key on your calculator. So calculator input here looks like 145 times 1 E3. So this E means times 10 raised to whatever number you put next. And then you can square that, and it'll treat this 1 E3 as a single number. So you don't have to worry about it for order of operations. And then we're going to divide by 247 and divide by 1 E3. And that'll give us that number there. Right, moving on. So a drop of gasoline has a mass of 22 milligrams and a density of 0.754 grams per centimeter cubed. What is its volume in cubic centimeters? So again, looking at these sort of things that are given, and 22 milligrams is not a conversion factor, but this density can be used as a conversion factor, and it says it here in the title of the slide. So we want to start with that 22 milligrams. And then we want to convert that into cubic centimeters. I'm just going to put this way out here because I've been running out of space. So 22 milligrams, we need to get that into grams so that we can use our density. So 1 milligram, it's going to be 1 times 10 to the negative 3 grams. And now once we have units of grams there, we can use this density, but we're going to need to flip it. So the way it's written here is kind of written as 0.754 grams over centimeters cubed. We're going to have to put that 0.754 on the bottom and the 1 centimeter cubed on top. This means that our grams can cancel out. And hey, look at that. Now our units here match our units here. And so we can calculate for our final answer. So 22 times, again, 1e to the negative 3, using that e key, and then divided by 0.754. So I'll have 2.9 times 10 to the negative 2. And why do we use just 2 sig figs here? Because our initial has just 2 sig figs. Okay. So now here is slide 56. So find the density in grams per centimeter cubed of a metal cube with a mass of 50.3 grams and an edge length of 2.65 centimeters. And we're told for a cube, volume equals length cubed. So we're given a few things: the mass of the cube in grams and the length of one of the edges of a cube. Here you kind of need to have the prior knowledge that a cube's length is the same on all sides. So we need to first find the volume of the cube. So volume equals the length cubed. So volume equals 2.65 centimeters cubed. 2.65 raised to the 3. So the volume of the cube is going to be 1.860965 times 10 to the 1, because my calculator is in scientific notation. So it's automatically giving me this, but it's 18.609625. Okay, short interruption there. And the units on this are going to be centimeters cubed. Now that we have that, we have the units of centimeters cubed here, and we have the mass here, we can take our 50.3 grams divided by 18.609625 centimeters cubed. And that 18 points, all of those digits, we're keeping all of those digits because that wasn't our final answer. How many sig figs, though, should that have? Should have 3, because we started with 3 here, and when you cube something, that's the same as multiplying it by itself 3 times. I guess you're multiplying it by itself twice. And now we can take 50.3 divided by 18.609625, and that will give us 2.70 grams per centimeter cubed, and that is our density. A couple extra significant figures and calculations here. So going to have to work stepwise on these because we've got mixed operations, we've got division, and we've got subtraction. And so we're going to start in the parentheses, follow the order of operations. So 232.99 minus 232.1. That'll be 0.89. But because this is subtraction, we're going to use the smallest number of decimal places. So 232.1 only has 1 decimal place, so that means that this 8 is our only significant decimal place. And then we can do our division, 5.3531. And notice how I'm not actually rounding off the 0.89. That's because we want to keep all of those digits because we're not done with our calculation yet. And when we divide that, we get 0.1662588, more decimals than we need. Now we're doing division. This has 5 sig figs. This has 1 sig fig. So our final answer has 1 sig fig. So this will now become 0.2, and that would be the answer. If we take a look at this next one, again, we want to follow the order of operations. And since we're starting with a multiplication, we're going to do 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Those both have 5 sig figs. So 3.1410 times 2.4367. And that's going to be 7.653647. But we're only keeping 5 of those. So it's 1, 2, 3, 4, 5. Those are the sig figs that we're keeping. And then when we subtract 2.34 from that number, we end up with 5.3136747. And now, because we're doing subtraction, we're keeping decimals decimal places. So 5.31, keeping 2 decimal places, 5.31, the answer for that. Final problem here, doing some unit conversions with cubed units. Start with 195, because that's the number that we're given. That's nanometers cubed, and we want to go to centimeters cubed. So a nanometer, I believe I mentioned this one in lecture, N for nano, N for 9. So 1 nanometer is 1 times 10 to the negative 9 meters. But then we need to cube that. And then we want to go from meters to centimeters. So 1 centimeter is 1 times 10 to the negative 2 meters. And then we need to cube that as well. So when you type this into your calculator, it should look like this: 195 times 1e negative 9 raised to the 3. Some calculators actually make that an exponent, others do not. And then this will be multiplied, but divided by 1e negative 2, and that raised to the 3. So 185 times 1e negative 9 raised to the 3, divided by 1e to the negative 2 raised to the 3, and 1.95 e times 10 to the negative 19. Cool, I hope that helps. Feel free to re-watch these as many times as you want, of course. All right, have a good one.